All right, I want to talk a little bit more on impulse and how it equals change in momentum. So here I have my two equations. Momentum is mass times velocity, and impulse is force times time. So using symbols, I remember momentum is a P, mass is an M, velocity is a V. Impulse, I use an uppercase I, is going to be force multiplied by time, T. So I'm going to be using these symbols, but the words are also the same. So let's say I had a momentum of 2,000 units, or 2,000 kilograms meters per second. These are my momentum units. I could have a bunch of different combos of this. I could have this be 50 kilograms times 40 meters per second would give me this. I could have a combo of 100 kilograms times 20 meters per second. Or I could have 200 kilograms traveling at 10 meters per second. You can really have an infinite number of these. I could have 2,000 kilograms traveling at 1 meter per second, but I'll just limit it to these three. So all three of these give me 2,000 units of momentum. Now, when I'm talking about impulse, I'm using a force times a time. So let's say my force is going to be negative 100 newtons. How long would that take me to stop all three of these combinations? Well, that would actually give me 20 seconds, and I'll show you why that is. So my impulse here, if I'm applying negative 100 newtons of force for 20 seconds, I multiply it by my time, I'm going to have an impulse of negative 2,000 Newton seconds. Newtons times seconds. Now, negative 2,000. 2,000 is familiar because that comes from my momentum. And my impulse here actually equals my change in momentum. Equals change in momentum. So my momentum went from 2,000 kilogram meters per second, and it changed by negative 2,000. So in the end, my momentum is zero because the object has come to a stop. Symbolically, I would write impulse is equal to delta P. Delta is the Greek letter, and it means change in. So my impulse will change an object's momentum. It can make the momentum get higher, or it can make the momentum get smaller. Either way, an impulse is a force applied for a certain amount of time. Now here, I want to talk about my units for a second. So I'm going to do this at the top. Units for momentum and for impulse. So for momentum, I know that my units here are, I'll draw these over here. It's mass times velocity, so I always get kilograms times meters per second. Now for impulse, I get newtons times seconds. Now this is where I want to focus on. Newtons is actually a combination unit. If you remembered, force is equal to mass times acceleration. So 1 newton is actually a kilogram times meters per second per second. This is a newton right here. It's a combo unit. And then I multiply that by seconds. So my units for impulse, newtons times seconds, if I write it like this, my seconds actually cancel, and my units for impulse are actually kilogram meter per second. The same as momentum. These have equivalent units. So if I have a Newton second here, this will change an object's momentum. So if I had taken any of these combos and applied a positive 1,000 Newton force for 20 seconds, the momentum would have gone up by 2,000. So rather than being 2,000 kilogram meter per second at the start, it would have gone up by 2,000 and be at 4,000. So for the 50 kilogram object, this would have doubled. Same for these. These all would have doubled because rather than slowing it down, I would have been increasing its momentum. And that is where we'll end this lesson.